Now, when you burn hydrogen, you cannot see it, nor smell it, or taste it. It's a very clean burning fuel. You're going to see a small part of the flame. Don't let that bother you. It's well over 5,000 degrees. The part of the flame that you'll see is the ambient air that's being mixed with the hydrogen and oxygen gas to support a pure hydrogen and oxygen flame, which is well over 5,000 degrees. Whoa. Okay, now set it up. Yeah, it's there. Turn it out now. Now, see that flame? Now, you're witnessing for the first time, in a true scientific terminology, the ability of burning ordinary natural water. Now, we're sustaining the production of hydrogen gas at the same rate of the generator. Now, we are adjusting the hydrogen burn rate automatically down to around 47 centimeters a second. Now, what Charlie's doing is taking an ordinary paper clip that has a high metal alloy in it, and as you see that hydrogen flame is actually melting that paper clip. Now, it's not the size of the flame that counts, it's the amount of energy that's being released from the flame. Charlie's taking the match and trying to expose it to the paper clip. It would take a flame well over 200 times greater in size and energy capacity to get it to a point of trying to melt it. Now, if you don't believe me, go home and take a butane torch and try to do what we're doing with ordinary natural water. And we're releasing the energy under controlled state. Now, I want this gentleman here, if you put your hands on the fuel cell and tell me if it's cold or hot. It's a cold process, right? We are using the water as a gas mixing regulator and producing the energy on demand basis. And as you see, Charlie can take it and use it as virtually as a cutting torch. Now we're going to demonstrate that because we're using the water as a gas mixing regulator, we can maintain the combustion rate of the gas irregardless of the generator. Turn the lights back out so we can demonstrate this. Now, to demonstrate this is that hydrogen burns in a very narrow window. But because we're using the water as a gas mixing regulator, we can control the combustion rate of the hydrogen gas regardless of the rate of the generator. Now, I'm having Charlie lowering the voltage, and as a result, you're going to see the flame go downward, but the flame is maintained. Now this is very important because we can maintain the combustion rate regardless of the rate of the generator. We now can hook it up to your car or hook it up to the furnace, or we can hook it up to some other form of energy device and know that we're going to maintain that combustion rate. Under prior state of the art, that was totally impossible. Now see the flame going down?
Now watch it come back up.
Now I'm going to have Charlie up the voltage, and now you're going to see that the hydrogen flame is increasing. All right, now I want you to tell me again, is the fuel cell hot or cold? Still cold process. Now, I want you to put your finger on there and tell me if that's hot. Now, I did that. Is it hot or cold? Just a hair warm, right? Well, how can we support a flame well over 5,000 degrees? And now put your finger on it. Let me ask you a question. How can you be able to support a flame well over 5,000 degrees and yet this thing does not become super hot? The reason being is that we developed a patented quenching circuit which has the ability to prevent anti-spark back into the generator. This now makes the generator a self-sustaining or very self-style generator, because under Murphy's Law, whatever go wrong would go wrong. It's electronically interfaced. We could shut off the system if any form of malfunctioning would occur.
going to shut it off on me now that I'm playing with it?
Yeah. All right, put your hand again and tell me that's hot or cold.
Might be
Lukewarm.
just very little bit.
Just barely warm. Okay, now if you go sit down, we'll go on with our presentation. Now don't, yes.
How long would that speed have played?
Until the water go out of the fuel cell or reduce down that the water would go below the exciter element. In other words, you keep supported until you consumed all the water out of the process. Huh? All right, that's stainless steel, 304 material. Now, as I questioned this man earlier in the presentation about the water, he said he used natural water, right? No chemical additives, did not process it in any way. Hydrogen oxygen gas is now being combined with the ambient air that's in the water and adjusting the burn rate downward and supporting that high temperature plane.